Have you ever wondered what it actually takes to build a machine so massive that a single tire costs more than most cars? So powerful it can push through solid rock as if it were sand. Somewhere behind reinforced walls and restricted access gates, inside one of the largest heavy equipment production facilities on the planet, engineers and welders are assembling machines that will reshape mountains, clear forests, and build the cities of tomorrow. This is the world of mega bulldozer manufacturing, a process so complex, so precise, and so heavily guarded that very few outsiders have ever been allowed to see it from start to finish. Today, we're going to take you inside that hidden production line, step by step, revealing exactly how these colossal machines come to life. The scale of what happens inside a facility built to produce the world's biggest bulldozers is almost impossible to imagine until you stand next to the raw components before assembly even begins. Steel plates weighing several tons each arrive on flatbed trailers from foundries hundreds of miles away. These aren't ordinary steel sheets. They've been engineered through specific heat treatment processes to withstand forces that would shatter conventional metal in seconds. Metallurgists inspect every single plate, checking for microscopic flaws using ultrasonic testing equipment that can detect imperfections invisible to the naked eye. A single hidden crack in the wrong place could mean catastrophic failure once the machine is out in the field, pushing through rock and debris under extreme pressure. This is why the inspection process for raw materials alone can take days before a single weld is ever made. Once the steel passes inspection, it moves into the cutting and shaping area, where massive plasma cutting machines and laser cutters slice through the metal with an almost eerie precision, following digital blueprints fed directly from engineering software. Sparks fly in controlled arcs as the machines carve out the shapes that will eventually become the undercarriage, the blade, and the frame of the bulldozer. Workers wearing heavy protective gear monitor the process from behind protective screens, because even a small miscalculation at this stage can ruin an entire steel plate worth thousands of dollars. What's fascinating is how much of this process now relies on robotic arms working in tandem with human specialists, blending decades of manual expertise with cutting-edge automation most people never get to witness. After the initial cutting phase, we move into one of the most physically demanding parts of the entire operation, the welding bay. This is where the true skeleton of the machine begins to take form. Master welders, some with over 20 years of experience, work alongside automated welding robots to fuse together the frame components. The heat generated during this stage is intense enough to warp lesser materials, which is why the sequence of welds has to follow an extremely specific pattern designed to prevent structural distortion. If a weld sequence is done out of order, the entire frame could bend imperceptibly, throwing off alignment for every component that comes after it. Engineers monitor the temperature of the metal in real time using thermal imaging cameras, ensuring the structure cools evenly and maintains its integrity. This is the part where you're probably starting to realize just how many things could go wrong in a process like this, and yet these facilities manage to produce these machines with remarkable consistency. If you're finding this as fascinating as I do, make sure to drop a comment below letting us know what surprised you the most so far. Hit that like button if you're enjoying this deep dive into a process most people will never see in person, and subscribe if you want to keep getting access to these behind-the-scenes looks at how the biggest machines in the world are actually built. Now, let's keep going, because the story is just getting started. With the frame welded and reinforced, the machine moves into the undercarriage assembly zone, arguably one of the most mechanically complex sections of the entire build. The undercarriage of a mega bulldozer isn't just a set of tracks. It's an intricate system of rollers, idlers, sprockets, and track chains designed to distribute the machine's enormous weight evenly across the ground, while providing the traction needed to move through mud, rock, and unstable terrain. Each track link is forged separately and must be fitted with extreme precision, because even a slight misalignment can cause uneven wear that shortens the lifespan of the entire undercarriage by thousands of operating hours. Technicians use specialized presses to install pins and bushings into the track chains, applying tons of pressure to ensure a snug, long-lasting fit that can survive years of abuse in some of the harshest environments on Earth, from Arctic mining sites to scorching desert quarries. Meanwhile, in a separate section of the facility, the engine builds are taking place. These aren't ordinary engines. We're talking about massive diesel power plants capable of producing well over 800 horsepower, engineered to run continuously for thousands of hours under extreme load. The engine assembly area operates almost like a surgical theater, with technicians in clean uniforms carefully installing pistons, crankshafts, and turbochargers with torque specifications measured down to the exact Newton meter. Any deviation from these specifications could mean the difference between an engine that lasts 15 years and one that fails within months. Once assembled, every single engine is placed on a dynamometer test stand, where it's run through a battery of stress tests simulating real-world working conditions, monitoring everything from fuel efficiency to emissions output before it's ever cleared to be paired with a finished chassis. As the engine and undercarriage come together with the main frame, the machine starts to resemble something recognizable, but there's still an enormous amount of work ahead. The hydraulic systems, which control the blade, the ripper, and countless other functions, have to be installed with extraordinary attention to detail. These systems operate under pressures exceeding several thousand pounds per square inch, meaning that even the smallest leak or improperly sealed fitting could result in a catastrophic hydraulic failure once the machine is in operation. Technicians run pressure tests on every single hose and cylinder, checking for even the faintest sign of weakness before signing off on that section of the build. It's a process that leaves virtually zero margin for error, and it's one of the many hidden safeguards most people watching a bulldozer at a job site would never think twice about. You imagined that behind that massive blade, there was just a simple hydraulic arm, didn't you? The reality is that the blade control system alone contains dozens of individual components, each one engineered to withstand repeated impacts against rock, roots, and compacted earth without failing. The blade itself is cast from specially hardened steel, then reinforced with wear-resistant cutting edges that can be replaced once they've worn down from years of aggressive use. Watching this component get lowered into place by an overhead crane and bolted onto the machine's hydraulic arms is honestly one of the most satisfying parts of the entire assembly process, because it's the moment the machine finally starts to look like the powerful piece of equipment we all recognize from construction sites and mining operations around the world. Once the mechanical assembly is complete, the machine doesn't just roll off the line ready to ship. It enters one of the most rigorous testing phases in the entire manufacturing world. Inside a dedicated testing facility, often kept away from public view, each bulldozer is put through a series of punishing evaluations designed to simulate years of real-world wear in a matter of days. Operators drive the machine through specially constructed test pits filled with boulders, mud, and uneven terrain, pushing the blade against obstacles specifically designed to stress every joint, weld, and hydraulic line. Sensors embedded throughout the machine record data on vibration, temperature, and pressure, feeding that information back to engineers who analyze every single data point looking for any sign of weakness. If even one sensor reports an anomaly, the machine is pulled from the line and inspected thoroughly before it's allowed to continue through the process. What's remarkable is how much of this testing focuses not just on raw power, but on operator safety and comfort as well. Inside the cab, engineers evaluate visibility from every angle, ensuring the operator has a clear line of sight to the blade and surrounding terrain, which is critical when you're operating a machine capable of moving tons of earth in a single pass. Noise levels inside the cabin are measured and compared against strict industry standards because operators often spend 10 or more hours a day inside these machines, and prolonged exposure to excessive vibration or noise can lead to long-term health issues. Climate control systems are tested in extreme heat and cold chambers to ensure operators remain comfortable whether they're working in the Arctic Circle or the middle of a desert excavation site. After passing every stage of testing, the machine finally receives its exterior finishing touches. This includes the iconic paint job, applied in a specialized paint booth using an electrostatic process that ensures even coverage and long-lasting protection against rust and corrosion. Multiple layers of primer, base coat, and clear coat are applied, with the machine baked between each layer inside massive drying ovens to cure the paint at precisely controlled temperatures. Decals and safety markings are added by hand, with workers carefully aligning each one to ensure the machine meets both branding standards and critical safety regulations required for operation on job sites around the world. What surprises most people is just how much quality control happens, even after the machine looks completely finished. A final inspection team walks the entire machine from front to back, checking bolt torque, fluid levels, electrical connections, and hydraulic seals one more time before it's ever cleared for shipment. Any imperfection, no matter how small, sends the machine back for correction. Only once it passes this final gauntlet of inspections does the bulldozer get loaded onto a specialized heavy haul trailer, ready to be transported to a dealership or directly to a job site where it will spend the next decade or more reshaping the earth itself. Standing back and looking at the finished machine, it's almost hard to believe just how many hands, how many hours, and how much precision engineering went into creating something that most people only ever see pushing dirt around a construction site. Every weld, every hydraulic line, every carefully torqued bolt represents a process most people will never witness, hidden away inside facilities that few outsiders are ever permitted to enter. So here's a question for you. After seeing everything that goes into building one of these massive machines, what part of the process surprised you the most? Let us know in the comments below, and if you want to keep getting exclusive looks inside the world's most fascinating manufacturing processes, make sure you're subscribed, because there's a lot more hidden behind those factory walls that we're just getting started uncovering.